Hey everyone, Nitesh this side. Hope you are doing good. So let's start with the question. So the question is remove all adjacent duplicates in string 2. Okay. So you are given a string and an integer k. What you have to do? You have to do remove k duplicate removal consisting of choosing k adjacent and equal letters from s. Okay. So you are given a string s and an integer k. You basically have to remove the consecutive or the adjacent string, which are basically have equal same character and they having the length of k. You have to remove them. Okay, pausing the left and right side of the deleted substring to concatenate it together. Okay, so we repeatedly make k duplicate removal on s until we no longer can. Okay, so there will be no consecutive same character having a greater than length of k. You have to remove them. What you have to do, you have to return the final string after such all the duplicate removals have been made. Okay, it is guaranteed that the answer is unique. Okay, so let's understand with an example. Okay, so let's take this example. So we have D, we have E. So let's write it down. Like we have D, we will start from here. Okay, so we have take it. Okay, now we have different character E, we will take it. Okay, similarly we have now E again, we will take it. Now we again have E, we'll take this E also. Now, when you take this, you can see these three having the consecutive length, okay, and which is equal to 3 and it is equal to k. So what you have to do, you have to remove this adjacent character. So you will remove them. So your final, I mean, for the current string is now become this. Now you will move further. You will come to see there is again D. You will take it. Now you have a B. You will take it. Okay. Now you have a B also. You will take it. Now there will be C. Okay, three C's are together. Let's take it C, C, C. So it's C, C, C. Now, now you can see these three having a length equal to K. So you will remove them. Now your string become D, D, B, and B. Okay, we'll move further. Now we encounter a B. Okay, so now we get a B. So it's not necessary that always the characters are always adjacent. After removing you can see after removing these three C, these three B also are together. Okay, and you have to remove them also. So now this will become DD. We'll move further. Now we again encounter a D. So we'll take that. Now you can see these become length is K equal, it's equal to 3. So we'll remove them. So now final string is right now is empty. So we'll move further. Now we encounter a, we'll take it, and we'll encounter again a, we'll take it. Okay. So as you can see, this is the final output for our case. Okay. Let's take one more example. So let's take this also. So we have P, we'll take it. We have B, we'll take it. Now we again have B. Okay. So okay, so this time our k is equal to 2, so we'll remove them. So this is only P. Okay, so now we have C, we'll take this. Now we have G, so both G are together, so let's say we remove them. Okay, we'll move further. Similarly 2T will also together, so we'll remove them. Now we'll take this C. Okay, so we'll take this C and we'll remove them, so it will become P. Again we have 3I, so 2 will be removed, only 1 will be pending, so Pi. Then there is one more I is completed, so then there is P. Okay, we'll take this. Now we again have a P, so we will remove them, so this will become Pi only. Now we have 2A, we'll remove them. Now we have 2A, we'll remove them. Similarly we have 1I. Okay, we'll remove them and we'll take S only. So as you can see, final output is PS for this case also. Okay, I hope the question is clear to you. Let's see how we can approach the question. Okay, and you can also see for the example one, there is no consecutive length which is having a k equal to 2, so that's why we just have output. Okay, so let's understand within how to approach this question. Okay, so now let's see how we can approach this question is, so we need, if you can see how we can count whether the three E's are there, whether three C's are there. So how can we count? We need some sort of a frequency. Okay, so you will think you will use map. Okay, so if you use map, you can also do this question, but there is a problem. Let's say like after removing this 3C, okay, these 3b will need to be removed. But how can you confirm from map, like whether they are together or not together? Let's say there is one more character between them, let's say O is between them. Okay, so you don't have to remove at that time. If you use map, you have a B of frequency 3 and you have C of frequency 3, so you will remove C also, you will remove B also. But for this case you don't have to remove because it's like B B O B. Okay, so map approach is failing at this point. Now if you can see the question, what we need is we need to compare with the previous string. We don't have to go further, we just have to compare the previous. Okay, so what we can use, we will use the same frequency ideology, and we use a stack for this. Okay, so what we will do, we'll take a stack. Okay, so let me create a stack, and stack is of, you can say, of node type, and it is having two values: data, your current data, and its frequency, how many times it's there. Okay, so this type of stack will take stack of node. Okay, so we will start from here, and what we will do, basically we will check if the stack current element is equal to the, like it's like your stack dot peak element is equal to the current element of this. If it is equal to, then you have to increase its frequency, otherwise you just have to insert it. Okay, so let's say first case, like we will check whether stack dot peak is equal to D. So as you can see, our stack is right now is empty, so whenever stack is empty, we'll just push it. So we will push it with, you can see this is a node, we have correct value as data as D and frequency as 1. Now we'll move further. Our stack is pointing, our peak is pointing at this point, or let me call it top. Okay, so now we come at here, we will check whether your current element is equal to this. So you can see this is not equal to this, so we will just push it. We will just push it, and now top is pointing at here. Okay, now we'll move further. We again encounter a E. Now we will check whether it is equal to top. Okay, you can see it is equal to our top, so we will basically increase its frequency and we'll move further. And whenever its frequency matching with our K, we will just pop this element from the stack. Okay, now again E comes, so E is equal to your stack dot top, so you will increase its frequency. You have increased it. Now after increasing it, you will check whether your current index, your top dot index, if it is equal to key K, you will just pop up. So you can see its value is 3, so we will pop this, and our top is pointing at this position only. Okay, we'll move further, we'll come at here. Now again we will check whether this is equal to our top. You can see it is equal to top, so we will increase its frequency, and we will check whether its index is matching to K. No, it is not matching to K, so we'll move further. We'll come at here. Now we again compare this, B is equal to D. No, it is not equal to, so we'll just push it. Now top is at here. Okay, now we'll move further. We again encounter a B, so we'll increase its frequency. Now we'll again move further. So this character is not equal to, so we'll create a new node and we'll insert it, C1. Okay, and top is at this position. Now we'll again move further and we see a C, so we'll increase its frequency. Okay, 1 second. So we increase its frequency and we'll move further. We again encounter a C, we will increase its frequency, and now you can see its frequency is matching to K, so we will pop this, and top is now at this position. We'll move further. You can see this is equal to your top, so you will increase its frequency, and your frequency is equal to K, so you will also pop this. Now you will move further, and you will, now your top is at this position, you will increase its frequency, and its frequency is equal to K, so you will pop this also. So now your stack is becoming empty. You will move further and you come at this position A, you will push it. You will again, you will move further, you will push it in the stack. So you can see this is your final stack. Okay, So now this is in the stack. Now we need to convert that into a string. So what we will do, we will basically loop over from our stack from top. Okay, and we will, for every index we will take that string. So for this it will be a and a, and let's say if your stack is like this, b1, okay, then your a2. So what you have to do, you have to take b, then you have to take a, then you have to take a, and this is like stack is taking in the leaf like last in first out, so we have to reverse this. So for this it will be a b. Okay, I hope the approach is clear to you. Let's write the code. Okay, so what we need a stack of node, and we'll take a stack. Okay, let me create a node class. Let's give a data, and let's give a frequency. Let me create a constructor char d and int f, data equal to d and your frequency equal to f. Okay, now we have to iterate over our string for character c s dot to char array. So what we need to check whether it's like if our stack dot, you can see peak is and its data, if it is equal to your current character, you will do something. Else it pretty simple, you just have to push it. Stack dot push, you will create a new node and you will just push c comma 1. Okay, now what we write, we have to write in this. So in this we need to write one more condition. Let's say if our stack is empty, so we need to check your stack shouldn't be empty for this condition to check. Otherwise, if stack is empty, just push it to the stack. Okay, so what we will do, we will first pop that element. So we will pop that and we will increase its frequency index, sorry, frequency plus 1, and we will basically again push it to the stack. Okay, so we just remove it from the stack, we increase its frequency, and we again insert it to the stack. Okay, so this is the main step. Now you need to check for the condition. Okay, so if your like stack is not empty and if your stack dot peak dot data, not data, this time it's frequency, if it is equal to k, just pop it out. Okay, stack dot pop. Okay, so we have done the main logic for our stack. Now we have to convert that stack into a string. So let's take a string builder, new string builder. Okay, so we'll loop over our stack while stack is not empty, and let me take the element out from the stack, stack dot pop. Okay, so we'll take our index, or let's take frequency, remove dot frequency. Okay, while our frequency is greater than 0, we will push it to our builder dot append your remove dot data. Okay, after this we just have to return this builder and we have to reverse it. Okay, reverse and do toString. Yeah, I think we have done with the code. So yeah, looks good to me. Let's run it. Okay, let's see if this is submitting or not. Yeah, this is accepted. Let's submit it. Yeah, our code is submitted. Hope you like it. Thank you for watching video, and do join the Telegram group if you're in doubt and in concern. Thank you.